Okay, so I got a really short video this week, and part of the reason that the video is going to be pretty short is because this week I had to get the program set up to read these sensors, and that took me quite a while. And I haven't done that in a long time. I haven't worked on much programming at all in a long time, and I've never been that terribly good at it. But it's something that I do from time to time, and it can be very difficult, but if you can get your stuff to work, it's actually kind of rewarding. To start out a little bit, I'll talk about what these are and what that chip is. And so one of the names for this chip here was an HX710B. And another name for it was and what it actually says on there is a TM7711. And apparently what it is a 24-bit analog to digital converter. And now what's kind of interesting about that is it's kind of similar to the chip that's on here, and this is the same type of board that I have reading in the data from the load cell out in the dyno, and what that is an HX711. So when it came to the code, you know, when I ordered these things, I noticed in the comments that well, I got it off of Amazon, and I noticed in the comments down at the bottom that there were people that weren't too happy with these things, and their biggest complaint was that there wasn't any support for it. And that was kind of true. There wasn't a lot of support for this chip here. After doing a bunch of looking around, I found that some people, at least one person anyway, had figured out a way to use the programming support for the HX711 on this HX710B. So it was a bunch of looking around I had to do, and where I found some support was on GitHub. And what I did was I just went to GitHub, and if you're not if you're watching this, I'm going to assume you know what GitHub is. So on GitHub, I just went to their search, where you can do a search, and I just searched HX710B, and a few results came up, but most of them were for Arduinos, hooking this up to an Arduino. So I think the code was written in like C or C++, but there was one program there that somebody had been working on to connect this to a Raspberry Pi, and that program was in Python. So, and that's the one I used, but it wasn't, I guess what I'll say is that I hardly have ever written a computer program from scratch. Usually what I do is, if there's something I want to try to get connected or use, and I need some program support for that, I'll just look around and find something that somebody has done that's kind of similar to what I want to do. People will share their programs quite generously, and that's what GitHub kind of does. And well, that's kind of what's on GitHub. Is a lot of times it's software that people are sharing with other people, and that's really, really helpful. And I appreciate those people that do that, because if it weren't for people like that, I'd have an awful hard time getting just something like this connected and transmitting data. So, at any rate, I got a program from GitHub that somebody made, and I'll somehow or another I'll tell you kind of how to get to there. Well, actually I already kind of did. Just go to GitHub and search HX710B and look for pretty much the only Python code there for a Raspberry Pi, and you'll find the programs that I used. Whoever wrote the program has multiple versions of the programs, and I guess the latest ones seem to be the ones that work the best. The other thing is, this is the Raspberry Pi that I got. I've already got two others in the data acquisition cabinet out in the garage, but it's I heard that there's a Raspberry Pi 5 out now, but I'm familiar with this one, and that's why I got the Raspberry Pi 4 Model B. To talk real briefly about the programs, and I've already stated that I'm not a coder and I'm not an expert with this stuff, and it was really a struggle for me to get what I got working to work. And what it kind of, the program's a Python program, and there's a library for the HX711, and I think what apparently the author of that software did, or the author of that program did, was I'm guessing that they did some work on maybe they didn't have to change much at all, but I think they did some work on a library for the HX711 to get that library to work with this chip here. The thing that held me up quite a bit was I had to learn about how Python programs use libraries and where the library has to be in order for the program that I'm using to find that library. Okay, so that took me quite a while to do, and I'll just briefly kind of show that what I kind of had to find out. So let me move over to the computer screen, and we can have a look kind of at that. This is the command line on the Raspberry Pi, and what I'll do quickly is show you. We'll do a GPIO read all. Oh, something I want to say before I go a whole lot further is that when it comes to this, a lot of the documentation, well, at least in some places, they say to use a 5-volt source for that VCC there. Now, that would probably be for a Arduino, almost certainly for an Arduino. But the Raspberry Pi uses a 3.3 volt logic, so you want to connect these to a 3.3 volt source, or else you might damage your Raspberry Pi. So we'll just do a GPIO read all, and I can kind of show you some of where I have these things connected. So I'm going to refer to these pressure sensors as pressure sensor A and pressure sensor B. So pressure sensor A, I have that connected to this 3.3 volt source here, and it's connected to that ground. And I can't remember which one's which, but it's using these two 5 and 6 here. And the program uses the BCM, or GPIO pin number designation. So it uses 5 and 6. I can't remember which one was data and which one was clock, but pressure sensor B is connected to, it's using that 3.3 volt source there, and it's using that ground there. And it uses pins number 19 and 26. And I do remember I have that written down here. Pin 19 was the data, and 26 was the clock. So probably 5 is data. Actually, I could probably see that quickly enough. Yeah, so it looks like what I've got here for the other one is that's data and that's clock, but I can't see it too good for now. But basically that's how and these pinouts correlate to positions on the GPIOs for the Raspberry Pi. I guess what we'll do next is just kind of show you some data coming in, and that's the Python code that we'll just show you that code running. And that thing there was I was going to do some data averaging for a while, and but for the time being, and it was just going to be like let it stabilize for a little bit. And you can kind of see, like, once in a while you'll have this like blip of a really high number coming through, and I'm not sure why that's doing that. It could be noise, but I was going to try to do some averaging, and it wasn't working out. I just want to get this. We're just going to use the raw data for a while, and maybe later on, maybe we can do some data smoothing and stuff like that to get the numbers coming out of it. So at any rate, now what it's doing here is it's reading these numbers are coming from those pressure sensors. This is a pressure sensor A, and that's pressure sensor B. So what I'll do is just I'm going to apply a little bit of pressure to the, what is this number part? This is the pressure sensor A. I'm just going to apply a little bit of pressure to that, and we can kind of watch that. Should be this one here that the cursor is next to. We should see that kind of. and then relieve the pressure, and the number comes back down. And it is kind of, I've noticed, like, if I hold the pressure sensor in my hand the wrong way, or hold onto it too tightly, it'll affect that number. Like, I'm kind of like squeezing it a little bit now, and you can kind of see the number moving around. So it's kind of touchy in that way. But I think that once I have it mounted to something solid, and maybe inside of the metal enclosure, that in case some of that, it's possible some of that is electrical noise, maybe coming from me. So, but yeah, you can see that number went up after applying the pressure to it. Come back down, and the other one at the same time remained the same. And now we'll just do the same thing with the sensor B, which will be the lower of the two. So I applied a pressure to it and then released it, and the numbers went up and down accordingly. So numbers I think I can use there, and the idea is going to be that I can use the digital manometer that I've got to calibrate these sensors to it. So kind of what I've had to figure out is that, now you're not going to want to quote me on this, but basically what it appears is that this is like the file name of the library, and this is like the name of the class in that library. So I don't know how that part of it there works, but apparently this part here is the name of the file. And what I had to figure out here was where that file needed to be. In this particular case, where it ended up being was home, Dyno 4. There's a folder called .local. And then there was lib. I'm going to guess that stands for library. But after loading Python onto this, these files apparently got created. And then inside of this folder here, that's right there. You see how that HX710.py matches it's the same as that there. That seems to be the way that works, and that's what took me a long time to figure out. And it seems like I have a similar Python program in another one of my Raspberry Pis already, and it seems like on that one it puts these libraries in a different place. And so I don't know what's different about this one. Maybe it's a different version of Python. I don't know. Maybe the ones out there are older versions of Python, or an older case of Python. I'm not sure, but that's what I struggled to find out, and then I struggled to find out how to get the program to read more than one pressure sensor in the same program. I was struggling with that for a while, but after I figured out a few things, it started working. It started working out pretty well. And there were some other things about the way the original Python program that I got from GitHub was set up. I didn't really understand the way it was set up, and there was a while loop in there that I didn't understand how it was executing the commands, and I still don't really understand how it did it. But I changed things enough to get it to do what I needed it to do. So there it is. That's all I got for this week. I know that's not very exciting stuff, but it took me a long time to get there, and it's just because this isn't something programming isn't something that I do frequently enough to be like really good at it. I mean, like I said, I tend to like be able to fumble my way through stuff, but and that's kind of what I did here. There was like 10 times I just wanted to quit and give up on this because I didn't think I was ever going to get it to work. But after each time I almost gave up, I had some other ideas, like, oh, well, maybe it works like this. And then after doing that about 10 times and driving myself a little bit crazy, I finally got something that I think I can use. And so what we got to do next is, and I'm not going to do that in this video, but the next thing I got to do is get those numbers and get them calibrated and turned into pressures. And then we can take those two pressures and subtract them from one another and get a delta P. And once we have that delta P, we can put that into the equation that we saw before and hopefully start calculating some flows. And well, it's just going to remain to be seen whether or not this setup's going to be accurate enough and going to work well enough to give me usable data. Well, anyway, that's all I got for this week, and we'll see you next time.